Alright, here we are, and here I have the FASTA file for the assembly here. And so this is it. Now, I've actually already done this and gone through it. And what we end up with when we search, we're going to get very strong results for a region down here. So it's going to say that this region down here, about 6, 1, 2, 3, 4, 5, about this region right here, this region is going to overwhelm all the other results because this is identical um, to a particular vector that's used somewhere. And the blast results, it's kind of like Google. You search for something, and this is overwhelming our results. And so this region, what I found, doesn't let us get any good information if we let Genius do the analysis all by itself. It's because this piece really needed to be trimmed out, and I obviously didn't get that out of the lab. I didn't get this piece out. So let me show you what it does show us. So I'm going to take this sequence and we're going to hit blast. All right, and we're going to take this one here. This is the sequence that we're doing. We're going to do a blast in. All right. Oh, actually, here, your query is too long for Genius to send. So we may have to choose this one. All right, so because it was too long, Genius can't do it. Let's do it here. We're going to have to enter it ourselves. Now, I know what it's going to get when we do this. So we can cut and paste this right here. This is our FASTA file. So let me do that real quick. Oh, I have to cancel this. Okay. So I'm just going to do it the easy way, which is here, and then I can go Control C, and that will cut it. Now, there's probably an easier way to do this in here, but I don't know everything on this, but I do know I want to do a blast search, and I'm going to enter it this way. And I'm going to do Control V and put it in there, and it says it's too long to send to the NCBI. So this method is not a good method because our sequence is too long for the auto query. So we have to go here to the blast. All right, and we're going to go directly to the site. All right, it's going to open up blast like this, and this is going to be the website. We'll have to wait for it. It's going to open up in your browser. All right, now I'm going to put this sequence in there. So this is the assembly that we made, and I've used Control C to copy it. You could copy it somewhere else and create the file and then go find it, but this will work. I'm going to go Control V, and this will be a FASTA file. Let's make sure it got the top. Yes, got our FASTA file. And then you scroll down, and we're just going to leave it. I'm going to make it show in a new window. Not a big deal. The rest of it you can leave the same. And I'm going to let it do a blast, and it's going to give us some results. I've done this already. So I know what we're going to get, and it's going to be something we don't want. And let me show you what that is. And it's all this cloning vector stuff. And we don't want that. We do not want that interfering with it. Now here we kind of get some other things that are going on. But we would really like to get rid of this cloning vector. I don't think that's what we were supposed to be searching for. And if we look at this, all right, it's going to tell us where that piece is. So I'm going to click on one of these, and I'm going to go to Summary, and it's showing us it's mostly here at the end. Here's the alignments, taxonomy, the descriptions, but the graphic summary. And what I want to do is I want to get rid of the end. And so what I did, I went and looked and I searched and I found the places where the end was giving us a problem, and what I figured out was, and now you would have to go through this. Let's see if I can do the graphics here. Will it give us? Hold on. No, that's not at all what we want. Okay. So go back to Genius. I would like to do all of this in Genius. Let's see if I can figure out another way to do this for us. Blast. Okay. So I did it the just standard way. Let me show you what we find. Now we have sent this off, and it's going to, well, what it's going to find, if you do it the standard way described in the manual, it's going to give you this, and we're going to find that all of our hits, and hit means we found something similar to our sequence, are going to be a cloning vector. And so we failed to eliminate that, and here are our hits, and it's telling us all about this vector and where it is. So I'm going to click on this, and it's found this. It's this piece down here, and so it's aligning with a piece of our sequence. Hold on. And where was that? Let me see if I can find the fragments. Text view. Here we go. Not the one I wanted. Let's just do one. Ah, here we go. Here's the piece I wanted. So I would get FastA alignment view. And what it is, this is our piece. This is the thing we sent to Blast. And then here are the hits that we got for the rest of these. So here's ours above, starting here, these were the hits. This is us, all right, and here. And if you go to FastA alignment view, and what it's doing, each of these pieces down here are hits from some other gene or something that they have stored in the database. And these are all vectors that are confounding our results. They're overwhelming our results so that all we're finding, and it's all this piece, if you'll notice down here. So the piece that's aligning really well is down here in the bottom. It's 1, 2, 3, 4, 5, about 6 lines up. All right, again, about 6 lines up. All right, so it's the same piece over and over. So what happens is we need to get rid of that. 1, 2, 3, 4, 5, 6. We need to get rid of these 6 lines and start where the CAC is. All right, so this is the piece that we want to save. All right, oops, right here. So about right here is the piece we want to search with. All right, this needs to be a FastA. Now I can't right click and copy it, but I can use Control C. So I'm going to use Control C, and I'm going to copy that. And I'm going to go back over here, up here to Blast. All right, and oh, do I already have it open? No. So this sequence. Okay. Well, we want to go to Blast, and it would send us there from here. I've copied it, so let's do it that way. No? go. It's giving me an error. I haven't seen. Why is it giving me an error? Do it from here. No. Oh, I'm clicked on this. Okay, unclick it. There we go. So now we are in Blast, and it says put it in there. But if I put this in here, it's going to be too long. I actually have to go here to the NCBI via the website. So I have to click here, and that piece that we just had, I did a Control-C and copied. We're going to have to put in here. We'll have to do it manually like this. So that's going to be Control-V. And so let's make sure it's what I want. Yes, it starts there. And it should end with CAC. Yes. So that was that piece that I wanted. That was under the FastA alignment view. So what I did, these are the pieces that were a problem. And they are 1, 2, 3, 4, 5, 6. About 6 lines up. So I am self-trimming, if you want to call it that. I am taking the bottom 6 of my lines, and I am taking them out of this because this piece right here is finding a piece out there that is a vector, and it's overwhelming our results, and I need to take that out if I'm going to find what is actually similar to the piece that we're interested in, which is everything above that. So I have grabbed that and I have put it into Blast. Oops. I've put it into Blast here. If you're not familiar with Blast, Genius opened this up for us. You can click on that on the place I clicked, which was where I have to click this, and then it was the second tab. I don't want to click on it again because it'll do it. So go back and watch this again where I clicked. And what it'll do is it'll open up Blast for you. And here we are. And I am going to search for this. Here, let me close that. That's not. And we can leave everything the same. You don't have to do anything. I click Show New Results in New Windows. You can leave everything here as it is. And you can hit Blast. And then we will do this manually. And unfortunately, this is what you're going to have to do, it looks like. And then you can get your results. So hopefully these are results that are interesting to you. Alright, I don't know exactly what we're expecting, but these are the things out there that are known that are similar to the sequence that we just sequenced. Alright, and how similar are they? Well, they're very similar towards around 1600. Alright, some around 400 and 800. These first two, the first two hits of what we've got, a hit is something you found that was similar, are by far the most similar, and here are the regions of the sequence that are very similar. So this is telling you that between around 1200 to a little over 2000, very similar, and we get some around before and after 800 and some a little bit after 400 for this one. So this first one is the most similar, and these are the regions in it that are the most similar. So let's go kind of look at our results here. That would be this one. So this one is our gene, and what is it? Only 39% coverage, but a very high E-value, 75% identity. So I'm going to click on this, and let's find out what this is. This Vincomycin cultivar glycerhydrol 3-dehydrogenase GAP2C. So, yep, that sounds like something similar to what you guys were sequencing. And this one is the highest hit out there. And so let's look at the FastA for that one. Okay, so here is the FastA for this one. I'm actually going to save this. I'm going to do it the old-fashioned way here. I'm just going to do it real quick. I'm going to grab this. I'm going to go copy. And I'm going to go back up here, and I'm going to make a FastA. And I'm going to save this. Alright, as a result. Okay, and I'm going to save it here inside our folder, Biorad. Alright, and then I'm going to go here, and I'm going to go back to our FASTA alignment. I'm going to make a FASTA real quick of this. So I have this whole one, including the part that we cut out. I'm going to go Control C, alright, and I'm going to make another FASTA. Alright, I'm going to call it our assembly. New assembly, I guess. It really is the same one, but it needs to be .FASTA. The other one does too if I didn't save it as a FASTA. I don't think I did, so I need to go do that. This one needs to be saved as result1.FASTA. Alright, so I have two FASTA files there, and what we're going to do is we're going to go back to Genius. I'm going to close out all this blast stuff. Alright, and we are going to go to Genius, and let's see, I do believe it has a dot plot program, so let's look for a dot plot. Exact brass primers, no, sequence. Here, new sequence would have been my editor I was looking for. Well, I was sure it had a dot plot program. Maybe this version doesn't because it's not the full version. No, it obviously does not because it's not the full version. So, let's go do something else. I'm going to go and I'm going to find a dot plot program. Oop, I didn't want to do that. I want Firefox. Okay, so let's see. Daughter. Not that one. I'm going to have to put in bioinformatics before it, or daughter program. There we go. Okay, here's daughter. And let's see. This one's the downloadable version. I want the online version. No. Tools. Oh, I can do this one. Dot matcher. Okay. So I want to put in my FASTA files. I could paste them in here, but I will browse, and I'll go to desktop, Biorad, and I can put in my my FASTA files. Let's see, result1, and then down here I'm going to put in let's see, it was result1 and something else. What did I call it? That was that one. New assembly, that was it. Alright, so these two, we will leave a window size of 10, that's about right. Threshold 23, that'll work. And we will run dot matcher. And what we're going to see is how these are similar. and unfortunately it's showing us they're not very similar. We need to adjust those parameters. So let's reduce this to about 7. Now you're not going to know what to put in here. A little better. Okay, so here is where they are similar. Not so much at the end, indicating that's the part we took out. Also, now it's showing in reverse. Let's see if I can find a better dot plot program. I have one here. Let's do this. I'm just going to use the one I have. It's old program. But let's put in this sequence. Where was that? That was under Biorad. And we need result 1. And we need new assembly. There we go. So here are 2. We're going to do this. Now we're going to click here. So 5. And we will reduce this a little to about 85%. Alright. We don't need inverted repeats for this. So there we go. And so here are our regions. We can probably clean this up a little. Let me do that. Clean this up. So I'm gonna leave it at 5. No, nope. Let's increase that. Let's go up to about 8. And let's reduce this down to about 75. See what we get. Too messy now. Now you can't even tell. So let's go back up. Let's make it 95. Went the wrong way, I think. There we go. So what we're seeing is the pieces that are aligned really well with, here's our shorter one. It's going to be the latter end. So yes, these are related. Our vector it is down here. All right, and the pieces that are aligning between the two are these regions. All right, so those of you in bioinformatics, we would probably pull these pieces, find the sequences are in these regions along here, and we would look to see if maybe our active site, or maybe some of the that's where you're very strongly some motif like a alpha helix or a beta band. We'd have to translate this to a protein, but we could do and see if the structural, these are highly conserved structural regions. All right, we also would look for that. So that's for my class, but for this class, this is basically the region that is similar between the thing we searched for and the thing we got. Now we could do that for several of our results on the blast, and I already closed out the results. I just did it on the first one because that one was the most that had the highest homology. But the idea here is that yes, when you do your blast, it's a problem because these last 6 lines, 1, 2, 3, 4, 5, 6, right in here are part of the vector of something that shows up all over the place. And so it's just this region that you need to be searching on the blast with. Now, I don't know if everybody's going to have this exact same problem, but the very end here, the way I did the trimming and everything didn't get rid of this. I don't know if there's a better way to get rid of it, but that's the problem when we searched. It couldn't find the thing that was actually related to because there was an artifact left in it, and we needed to get rid of that. And that's about it.